To add or subtract rational expressions, we need common denominators just like fractions. So for this first one, you can see we already have common denominators, so we can just go ahead and add the numerators together. I need to distribute this negative on top here. That's going to give me 3a minus 2, which gives me 2a minus 2, or this. Of course, we need to note that a cannot equal 1 because that gives us a 0 in the denominator, and those cancel, giving us just 2, where a cannot equal 1. This is a little strange because there's no more, a is not involved in the expression at all. However, this is important when working with functions because though this function may just equal 2, a cannot equal 1, so there's going to be a little discontinuity at that point. Okay, for the next one, we're going to multiply each denominator by the other one. That's because we cannot multiply by anything smaller than this. There's no way to make p minus 5 equal to p plus 5 by multiplication except by multiplying by the other denominator. You can always do that. If you're not sure which denominator gives you common ones, just multiply by the other one and go from there. Okay, for this first fraction, we get p plus 5. For the second one, we get minus p minus 5. And of course, the denominator is the same for both, p plus 5, p minus 5. So from this, we know, of course, that p cannot equal plus or minus 5. That would give us 0 in the denominator. Let's simplify. P plus 5 minus p plus 5. P's cancel, and we get 10 over p plus 5, p minus 5, where p does not equal plus or minus 5. So common denominators, that's the important thing here. All right, let's look at one that's a little bit more complex, or complicated, I should say. We have a trinomial here in the first one. I'm going to factor out the 2. That's going to give me w squared plus 7w plus 12. And here I can take out a 2. It's going to give me 2 times w plus 3. Now for this first one, we have the AC method. We get 12 and 7. That's going to be, let's see, 3 and 4. 3 times 4 is 12. 3 plus 4 is 7. And since a is 1, we can use the shortcut. W plus 3, W plus 4. Okay, so that's our new denominator. And we're asking, what's the common denominator? So let me write this out a little bit bigger. Okay, so when you're trying to find common denominators, what you should be asking is, what does this denominator have or need that the other ones have? And this one has a w plus 4. Well, this one has a w plus 4 as well, right? This one has a 2. That one also has a 2. And this one has a w plus 3. Well, that one also has a w plus 3. So this first fraction doesn't need anything. The second fraction, it only has a w plus 4, which means it needs a 2 times w plus 3. So we're going to multiply top and bottom by that expression. And this final one, it does not have a w plus 4, so it needs a w plus 4. Multiply top and bottom. And now everything is going to have a common denominator. So for the first one, it's going to be the exact same thing. We haven't changed that at all. For this next one, I'm going to multiply these 2's together and give it a negative. So it's going to be negative 4 times w plus 3. And this last one is positive 4 times w plus 4. I've combined this all into one fraction because they all have the same denominator. 2 times w plus 3 times w plus 4. At this point, we can see that w cannot equal -3 or -4. Now all we need to do is simplify the numerator and go from there. So distribute the 4's. That's going to give me w minus 4w minus 12 plus 4w plus 16 over the same denominator as that one. Nothing's changed there with the denominators. Okay, now we can see that the w's cancel, and we get w minus 12 plus 16 is plus 4. And you can see, well, w plus 4 and w plus 4 cancel. Now, when everything cancels on the top, that does not mean you have 0 on top. That means you have a 1. Think of it like division. W plus 4 divided by w plus 4 is 1. So we have 1 on top over 2 times w plus 3. Where, of course, w cannot equal -3 or -4. And that's the simplified expression. Give it a try in number 3. Now, complex fractions are fractions within fractions. As you can see here, we have 3 fractions within this overall big single fraction. And we can actually make this a lot simpler by multiplying everything by the common denominator within each one of the smaller fractions. Here we have x, xy, 1, and y. So the common thing that everything needs is xy. That's the biggest thing. So if I multiply everything by xy, that's the common fraction, then this is going to become, on top, we're going to distribute the xy, on bottom as well. On top, xy over x, xy over xy. On bottom, we have xy over 1, and then xy over y. And here you must note what the denominator cannot equal. So of course, x cannot equal 0 and y cannot equal 0. X times y cannot equal 0. Well, that's just the same thing as x not equal 0 and y not equal 0. So now we can simplify this statement down. I can cancel out an x, an xy, and a y. Once again, make sure this thing just becomes 1. It does not go away, it becomes 1 instead. So we have y minus 1 on top. On bottom, we have xy minus x. I can factor the denominator by taking out an x. And before I cancel, I can cancel a y minus 1 on top and bottom. I must once again look at the denominator. I've just factored it, so let's ask, when is it 0? Well, when x equals 0, we know that's already the case. X can't equal 0. And when y equals 1. So we must exclude 1 from y as well. Now we can cancel. We get 1 in the numerator. We get 1 over x, where x does not equal 0 and y does not equal 0 or 1. And that's the completely simplified form. The main thing to note is that when you multiply by the greatest common factor the least common factor on top and bottom, when you do that, you actually remove all of the inner fractions and it becomes just a normal fraction, which is a lot easier to work with. However, you have to always consider, when are the denominators equal to 0? X, y, xy, right? 1 can't equal 0, so you have to consider that before you cancel anything. Give it a try in number 4. Now let's look at an application problem of these rational expressions. So the distance formula, which is d equals rt, this is the basic formula. It's very useful. D is just distance, r is the rate of travel, and t is time. Now, if we're going to take a trip to London, leaving from Atlanta, the flight plan that goes through, well, any flight plan that you will always fly on, will always try and fly with the jet stream whenever possible. The jet stream pushes along as long as it's a tailwind. So if it goes with the jet stream, it's got a tailwind, which means it pushes the plane faster, gets there sooner, uses less fuel. It's just always a good thing to fly with the jet stream whenever possible. And along this trip from London to Atlanta, Atlanta to London, the jet stream does tend to flow that direction. And there tends to be about 50% with the tailwind and 50% that's not affected much by the jet stream at all. So we're going to say half of it's going to be with a tailwind. So we're going to increase our speed by W. And the other half is just the speed of the plane. That's to make the mathematics simpler. Now, typically a plane that would do this trip would do about 550 miles per hour. And the actual distance that you're going to fly is approximately 4,200 miles. So what is a general formula that, for the time it takes to go to London? Well, the time that we're looking for, we're going to use the distance formula, but not in this form. Here we have what distance equals. Instead, we want the time. So we're going to divide by R, and that's going to give us D over R. Now, in this case, we have two different portions. 50% is going with the tailwind. 50% of the trip is 50% of 4,200, which is 2,100. So 2,100 miles goes with the jet stream, and 2,100 miles is a flat rate of speed. That means we have a different rates of travel for these different distances. And we can actually write that with the distance formula by doing distance 1 over the first rate plus distance 2 over the second rate. You're just breaking up the portions over each rate of speed that you're going and the distance that it travels. Now for us, distance 1 and distance 2 are the same. They're both 2,100 miles. That's because we had 50-50. But rate 1 and rate 2 are not going to be the same thing. So we have 2,100. The first rate is going to be the plane that flies with 550 miles per hour. And then with an increase of speed, if it goes with the jet stream, that means it's going faster. The jet stream is going W miles per hour. So it's going to be just a flat increase by just W. So the first rate is going to be 550 plus W. And then we're going to add that to the second distance is 2,100. And the second rate is just 550 miles per hour. Of course, on the right-hand side, we have a rational expression. And we don't really want to have this separated if we don't have to. Let's combine them into one thing. We need common denominators. The only way to do this is by multiplying by the other denominator. All right. Simplifying this down. We get this expression here, and I can combine these two like terms. Let's see, it's 1,155,000. I combine both of those, and I can actually factor out 2,100. That's going to make it a little bit easier to look at. That's going to be 100 or 1,100 plus W over. You can just check for yourself this is the case. And of course, we can reduce this thing. So divide top and bottom by 50. That's going to give us 42 over 11. We can't really cancel anything here. There's no common factor in top and bottom. But it is important to note that W cannot equal negative 550. Of course, if the wind stream equaled 550 miles per hour in the opposite direction, that'd be pretty fast wind stream. And so that's unlikely to ever happen in real life. Now, if the wind stream is traveling at 100 miles per hour, what time does it take? Well, all we have to do is plug in 100 into this expression here. So we're going to get 42, 110 plus 100, 11, 550 plus 100, and simplify. So on top we get 42 times 1200. On the bottom, approximately 7.05. And this will be in hours because we had miles per hour was our speed. Okay, now, how long is the trip going back to Atlanta if the exact same conditions and flight path apply? So instead of having a tailwind, now we're going to have a headwind. And really what we're saying here is if it's the exact same conditions, we have the exact same expression, what happens when W equals negative 100? Because it'd be pushing against the plane. So the plane's going to be going slower. Of course, in real life, there's no reason why they would do this unless they absolutely had to. But let's just assume this is the case and see what happens to the time of travel. Well, all we have to do is plug in negative 100 for W. And simplify. So on top, we're going to have 42, let's see, 1, 2, 3. 4950. And this gives us approximately 8.48 hours. So you can see the jet stream it could probably save us an hour and a half or give it, make it take an hour and a half longer, whichever way you really want to think about it. But it does significantly affect the travel time. So that's why it's important to always have the best flight plan available.